Hello, everybody. My name is Italo Oliveira. I'm a PhD student in computer science at the Free University of Bolzano in Italy. And here I'm going to talk about our work on an ontology of security from a risk treatment perspective. First, I'm going to present the motivation of this work, the requirements that we propose for the ontology, the ontological foundations, the ontology that we call a reference ontology for security engineering roles, and the evaluation according to the requirements and some final considerations. Consider that here I'm going to present some key points of this work, which is full of details. So if you want to check more, I recommend you to read the paper. So the research questions we have is how can we understand and conceptually model the secure domain in a general fashion? Because security is something that cross-cuts several different areas. We talk it when we have to use protection equipments in chemical industry or public safety, or in the context of pandemic, we use masks and other protection measures and cybersecurity and so many other domains. And the ISO 31000 talks about security using the term risk treatment. It's part of the process of risk management. How can we conceptualize this notion in a general fashion? So according to ISO 31000, the risk treatment options are the following: avoiding the risk by deciding not to start or continue with the activity that gives rise to the risk, taking or increasing the risk in order to pursue an opportunity, removing the risk source, changing the likelihood, changing the consequence, changing the risk, sharing the risk with another party, and retaining the risk by informed decision. So we wanted an ontology that is able to capture these risk treatment options somehow. And for that, we define some requirements. Analysis requirements are domain-specific capabilities associated to the tasks the ontology should help to realize. And since the ontology of security has to support activities related to risk treatment, or as we call security engineering, we need to go through a previous step of risk assessment. And therefore, the ontology shall support the identification and assessment of risks. It also shall support activities associated with security engineering or risk treatment in multiple domains. As I said, capturing risk treatment options according to ISO. And the ontological requirements are domain-specific concepts and relations that the ontology should have in order to represent the domain of interest. Okay. And they are the following. The ontology shall support the task of representing the risk treatment options according to ISO, something I said. It also should include both risk and security concepts and explain the relationship they have with one another. And some of the common concepts in security core ontologies, according to a literature review, are vulnerability, risk asset, attack, threat, control, countermeasure, stakeholder, attack, consequence, and ideally our ontology should be able to represent all these concepts. The ontology shall also be able to distinguish between intentional and non-intentional threats, because depending on which is the case, the risk treatment option may be different. We also define some quality requirements, domain-specific characteristics the ontology is expected to possess in order to be a better artifact. So domain appropriateness, it's about having a realistic ontology, an ontology that actually captures the relevant entities and relations in the domain. It should be general enough. As I said, security is very complex. And it should be fair in the sense of being findable, accessible, interoperable, and reusable. So let me talk now about the ontological foundations of this work. The ontology we propose, Rose, is a UFO-based ontology, UFO-based core ontology of security or reference ontology of security. And it makes use not only of UFO, but also a theory within UFO that deals with the phenomenon of prevention. And this phenomenon is when an event somehow prevents other events from happening, or when an event blocks an ongoing process, like when you put water on fire and then the fire is extinguished. So we build the ontology of security based on this theory of prevention. And here you have the theory of prevention in blue, and the other part is a piece of UFO. Notice that the theory of prevention takes into account the notion of causal likelihood or a certain probability of the advent of some types of events. That's just something that I highlight here because it's going to be useful later on. Moreover, since we have to take into account the risk aspects, we are going to reuse a modified version of COVER, the Common Ontology of Value and Risk, which is also a UFO-based reference ontology. So the idea is that the ontology of security is going to be an extension of COVER and the theory of prevention, now dealing with security aspects. Two key points about COVER that are important for our theory or ontology of security. Value is a relational property that emerges from the relations between capacities of certain objects and the goals of an agent. The idea is that the manifestations of these capacities are events that bring about a situation that impacts or satisfies the goal of a given agent. Risk is the opposite, it's the anti-value. Risk events are the manifestations of capacities, vulnerabilities, and sometimes intentions that inhere in an agent. These events bring about a situation that hurts a goal of a given agent. So you see that value and risk are kind of oppositions of each other. Now, the ontology of security is built as an extension of COVER, actually a modified version of COVER. And most of the concepts here are from COVER. The ones that are not, you see here, attacker, attack, in the concepts on the type level. And let me highlight a relation that's important here, the notion of mutual activation partnership. The idea is that some dispositions, okay, some properties, let's say, they need each other to be manifested. And in this case of risk and security, we are saying that threat capability can only manifest itself when it can exploit a vulnerability. And a vulnerability can only be exploited when a threat capability is manifested. So they have a sort of generic dependence relation between each other. And sometimes when there is an agent, an attacker, you also have intention as something that's necessary to the manifestation of the other two, right? This dependence relation among these properties. And now the security aspects of roles. The idea is that, like value, security is a relational property that emerges from the relations between capacities of objects and goals of an agent. The manifestations of these capacities bring about a situation that impacts the goal of an agent in a very specific way, preventing risk events. This means that security is the intersection between the theory of prevention and the domain of value and risk. And here you see that a security mechanism is designed by a security designer, and this uh, creation is meant to be a countermeasure to risk event type, to a types of events, okay? And the idea is that the manifestation of control capabilities of a security mechanism eventually result in the prevention of risk events. Let me go. And the way we propose roles is able to do several things. And according to the requirements that we propose, right? So as I said, roles incorporates a modified extended version of cover. And because of that, roles captures risk and value concepts that are necessary for supporting the activity of risk identification and assessment. And from the theory of prevention, roles contains this notion of likelihood, of causation between events, and due to that, Rose is able to support probabilistic assessment of value, risk, and security happenings. Moreover, Rose shows the ambiguity of risk treatment option, removing the risk source of ISO 31000. And this is so because there are actually multiple interacting entities that can be the risk source. For example, instance of threat object, object at risk, risk enabler, threat capability, intention, and vulnerability. It's possible to remove threat capability without removing the threat object, though removing the latter implies the removal of the former due to the existential dependence of disposition on the bearers. The point is that once you remove one of these entities, and because of the existential dependence of dispositions on the bearers, and because of the generic dependence of the relation mutual activation partnership, it means that if you remove one of them, you are going to prevent the risk event. So all these entities are potential risk source. Moreover, as UFO and OntoUML, the language we use it to represent the ontology, are formally defined in first order logic, having support for all implementation. Roles benefit from that in terms of formality and capacities, since it's expressed in OntoUML, right? Making use of roles for support formal reason is easier because of that. Finally, to make roles findable, accessible, We provide it publicly in a repository with related information in the link that you can find below. Concerning other capabilities, and in particular the quality requirements, we see that ROSE has shown a rich set of ontological distinctions thanks to the support of UFO and cover, maintaining generality, which is noted, for example, by the fact that the security mechanism can be object of different kinds, including physical and social objects, like, for example, lockdown measures. As final considerations, ROSE provides an ontological analysis of the notion of security mechanism, okay? As I mentioned, ROSE explains the security domain as the generation of value through the systematic and intentional prevention of risk events. ROSE was used to evaluate and redesign security aspects of Archimate language in the context of enterprise risk management. This is something that has already been done, and it was originally as part of our future work in this paper. So it's good that this is completed. We intend to test and validate ROSE using formal tools and also experts' considerations. And we intend to connect ROSE to other UFO-based ontologies, such as an ontology of legal relations. So here are the reference. Of course, there are many others in the paper, and I recommend you to check it out. Thanks.